Hi there. We're continuing this course by learning about data types. Now, this is a very important concept in programming generally, and SQL is not an exception. Therefore, I implore you to take it very seriously, because once you get the concept of data types, it will be easy for us to do a lot of things coming up in the future. Right. I'm going to bring up my slide and I'll walk you through understanding data types and all the data types that we have in SQL Server. Okay, so what do we understand by data types? Data types are used to define the particular kind of data item a column in SQL Server table can take. And depending on the values we intend to put in the tables, you'll make a decision on the data type to use. So what do we mean by this? Think about your Excel file like I have on the slide here. In Excel, you put in data there, you just bring up your Excel and then you start typing. You type in your number. For names, you just type in your characters. For dates, you just put in dates. You don't have to worry about specifying the type or kind of data, right? But it works differently for SQL Server, and I'll show you now. Let me bring up my SQL Server Management Studio, and looking at this on your screen is what you get when you try to create a table graphically. We will do a lot of this in the coming videos, where we will create tables using the graphical user interface, and we will also create it using SQL syntax. But bear with me for a moment, because I'm not going to show you how I actually got here so you don't get confused. But this is just the pain that you see when you want to create a table, and you can just specify the columns that you want to create here. So these are the columns of the table, and the one in the middle is the data type. So for ID, I am specifying int to say this is the kind of data that will live on this column. And similarly for first name, I have specified something called nvirtual, and I put a value 50. So this value can be changed. It could be anything. It could be 500. It could be not 5,000, but it could be 500. It could be 50. It could be 12. It could be 120. It could be anything. But we'll talk about what these numbers are, what nvirtual is, what virtual is, and all the things very soon. And of course, there is maximum to the number of numbers that you can write here, and I'll show you that as well. For date of birth column, you can see that I've specified date. So that's to tell you that if I want to put a column in the database, I have to tell it what kind of data would eventually come on that column. If I click on this down arrow, you can see there are a number of data types to choose from here, and it will be quite daunting if you don't understand what these things mean. You can't just be doing a guesswork here to say, oh, even though I don't know what it means, but let me just pick this. If you do this kind of thing, you will have a database full of bugs, and you'll be having errors. It's going to be hell, so you don't want to do that. You want to actually understand exactly what you're doing. So I'll minimize our Management Studio and go back to our slide. So we can see that there are a number of kinds of data item that we have. There is character or string, there is numbers, there is dates, and there are others. Now, going into the character data type, there are a number of character data types that there are, and as you can see, we have 6 here. We have text, we have ntext, we have char, we have varchar, nchar, and varchar. First and foremost, let's get rid of this first 2. The only reason that you still find them in SQL Server is for backward compatibility, meaning if like the most recent SQL Server as we speak right now is SQL Server 2016, and every now and often, roughly every 2 years, you get SQL Server to introduce new versions. But what happens to the old versions? They're still there because there are a number of companies who still rely on them, who have actually built them within their infrastructure. So for the latest releases to be compatible with the old ones, they tend to keep features that were in the old one in the new ones as well. So even though SQL Server, Microsoft has said that they will discontinue the use of text and end text, they still put it there for backward compatibility. So you don't have to worry about this because no one will ask you to use them anyway. So going forward, we're left with 4 other types of data types for character. And you would wonder, how can I make a decision between these 4? How would I know which one to use at a particular point in time? Well, the answer is very much straightforward. And it's straightforward because you have to answer some other kinds of questions yourself. And the question is, 1, is it Unicode or non-Unicode? We need to understand what Unicode means before we can understand what non-Unicode is. It's simple. Unicode means letters or characters that are non-Western, that are English, so to speak. So they're not your ABCs. So you can think about the Chinese language, for example. Those are Unicode characters. The $, the pound sign, the naira sign, all these signs and symbols that are not regular characters that we know, those are the ones that are called Unicode. So what are non-Unicode? The answer is there already. They are the ones that we know already. These are the regular ABCs that we know. So those are the non-Unicode characters. So once you've been able to identify that the data that will be contained in your database table will be Unicode, then what you want to do is focus on these 2, nchar and nvarchar. You see, the N there means Unicode. It's just strange that they don't use uchar or uvarchar, but for some reason they've chosen to use N. So anywhere you see nchar or nvarchar, you understand that the first N there means Unicode. And on the other flip, char and varchar. So if you remove the N, what you have is char. You see, if you remove the N here, what you have here is varchar. And what does char mean? What does varchar means? Char simply means character, and varchar simply means variable character. And that leads us to the second question you want to ask yourself and say, is it going to be fixed length or variable length? So if the length of your character is going to be fixed, then you want to choose char. If it is going to be variable, you're not sure if it's going to be 10 or 5 or 20, then you want to go for varchar. And thinking about that, there are penalties that you have to pay for choosing either of them, because Unicode characters takes 2 bytes per character, while non-Unicode takes 1 byte per character. So you don't want to use these things indiscriminately, because you might be shooting yourself in the foot if you just say, oh, because nvarchar, just takes both Unicode and non-Unicode, then let me just use nvarchar all the time. You need to bear in mind that it takes more space in the database. All right, moving forward, talking about the fixed length and the size and the variability and all of that, let's see nchar 10, for example, and this is the syntax really. If you want to specify a data type, you will give it the name of the data type and then you put the length in parentheses like that. So we have, so let's say for example I want to use nchar 10, meaning Unicode character in 10 places. Yes, now because it takes 2 bytes each, it will cost me 20 bytes plus padded spaces. Now what that padded spaces mean is that if out of this 10 all I used was 5, it's still going to cost me 20 bytes, and the remaining 5 from this 10 will be replaced by these spaces. So meaning you are forced to use all the 10. I mean, you're not entirely forced to use all the 10 to mean that if you don't use 10 it will throw an error. No, it will still accept the value, but it will make it up for additional white spaces, just like I have highlighted here, right? So that's something you need to bear in mind when you're using fixed length character. And for char, if I use 10, and remember it costs 1 byte, so 10 multiplied by 1 will be 10 bytes, and because it is fixed length character, it will still use white spaces. Even though I use 2, the remaining 8 will be contained with white spaces. Now going on to variable length character. Now this also takes, Unicode generally, whether variable or fixed, Unicode generally takes 2 bytes, right? And non-Unicode takes 1 byte. Now if I used 10 in this example, it's not going to forcefully take up 20 bytes. It can take up to 20 bytes provided I use everything. But if I decided I'm only going to use 5, then it will use just 10. You see, that's the difference. So, and again, it won't fill it up with white spaces. So all these things you have to bear in mind when you are making decisions about your data types. And for varchar, which is non-Unicode, takes 1 byte. So if I use 10, it will take, depending, it can take up to 10 bytes, or it could take 1. If I use just 1, it could take 2, it could take 3, But let me just say this off the record. You see, from my experience, most of the time I just use Unicode characters because it is safer. It's pretty much just safer because you can start up an application and use a non-Unicode, and 10, 15, 20 years down the line there may be business changes that now wants to accept Unicode characters. At that point you want your database to still be compatible for those kind of changes. So generally speaking, most of the time I use Unicode for my own work, but you can still do your own experiment around, do more research and come up with your own strategy. But I'm only telling you from my own experience point of view. Now moving down, there is a maximum number of length that you can specify, and for there's a maximum length of character allowed on a column in SQL Server. It is 8,000 bytes. So what that means is for your Unicode you can only specify a maximum of 4,000, because if you multiply 4,000 by 2 it will give us 8,000. And for non-Unicode, because it takes up 1 byte, all you have to do is 8,000 if you ever want to go that much. Now having said that, there is still another option which is called max, and with max it can take up to 2 gigabytes of space. And thinking about it, 8,000 bytes means 8 MB, right? But if you need to store up so much data, you can use max, and that one goes beyond 8,000. It goes beyond, it's just maximum, so you can bear that in mind. Okay, so we'll move away from character kind of data. Now we'll move into numbers. So there are a number of fixed length numbers. So there is ints, small ints, tiny ints, big ints, money, and all of that. And what makes them different is the amount of value which they can take up. So for int, for example, you can put in as much as minus 2 billion to 2 billion. I mean, in terms of numbers. So you can take up numbers up to 2 billion, like that. So I believe this is 2 billion, right? So it can take as much as this going up or as much as this going down, which is negative, because they are numbers. So this is the kind of numbers that int can take. And small int doesn't take that much. It only takes between 32,768 and minus 32,767. Now, tiny int takes between 0 to 225. Big int takes plus or minus over 2 billion. So if you ever want more than what int can take, then you want to think about big int, which takes more than 2 billion. And there are other ones for money. There is small money, and these are the values in which they take as well. So there's money, there's small money, there's decimal. Now decimal and numeric are the same thing. It's just a matter of backward compatibility, and decimal is the most recent, and it's the one that I'll advise you to use anytime you want to use something with fixed precision and scale. And I'm going to explain to you what that means. So let's say, for example, this is how to specify decimal. So you say decimal, and then you put these two figures in parentheses. And what that means is the first figure is the precision, which is this 5. And the other one is the scale, which is this 3. So what this means is it will take only this kind of data. So if you count these all together, there are 5 digits here: 7, 5, 6, 3, 5. So it is 5 altogether. But the scale there is, let's put this 2. So the scale there is 2, right? So if we have 5 and 2, what that means is we have 7, 5, 6, 3, 5, 5 altogether, and then after the decimal point we have just 2. If it was 3, that means it can take one more figure here. So let's say, for example, this was 8 and 3. So what this means is we would have 1, 2, 3, 4, 5, 6, 7, 8 altogether, and then we have 3 in the end. So that's what this means. So if you ever have to use decimal, this is how to use it. And the same thing works for numeric, but numeric, like I said, is just there for backward compatibility. It's the same thing with decimal. And there are other approximate length of numbers. There is float, there is real. These are not as common as the fixed numbers, but you'll find them in use from time to time if the figures are going to be approximate, not fixed. And moving on with data types, we will go into date. So if you ever want to store data, and if you put date just means date. It's only going to store the date. If you put time, it will store time. Now if you put date time, it will store both dates and time together. If you use date time 2, which is the one I use all the time, and it's the one I would recommend you to use as well anytime you intend to use date and time together, because it has more fractional precision. It goes to, as it's really fast. It goes as much as 100 nanoseconds. So let's say, for example, I want to store the current date and time right now. We have hour, minute, second, microsecond. There is a nanosecond as well. So it can store the nanosecond and up to 100 nanoseconds. So it is really, really effective in terms of the precise kind of date you would like to store. And then we have date time offset. So what this means is it is aware of time zones. So if your database is going to be used across the world where there are different time zones, it is time zone aware, and it can put that into consideration when putting the date in the database. And there is small date time as well. So what that small date time means is it's just a matter of the precision, the preciseness of the data that it can store. So it doesn't store as precise data as we have in date time. So that's why it's small date time. So moving on with data types, there are a few other ones which are not really used all the time, but you find them in use from time to time as well. So there's binary and there's var binary, and you can definitely tell the difference between the two from the concept of char and varchar, which is binary is fixed, var binary is variable, and we use both of them to store things like images, things like documents, like you have file attachments and things like that, so you use these kinds of data type to store them. So there is bit, there is XML. If you're from a website development background, you would understand what I mean by XML, or if you're from some other programming background, you can tell that XML it's like a semi-structured data. So because XML looks like text, right? You can store them in char or varchar column as well. But you have to bear in mind that if you do that, SQL Server will not understand that it is XML. So it won't be able to parse that XML file. Let's say if you wanted to query the XML file to extract data out of it. But if you put it in an XML data type, SQL Server understands that it is an XML file or data. And when it's time for you to use some XML related query, it will understand it, and it will be able to give you the kind of data you're after. Unique identifier is another one. It stores 16 digits unique ID, and sometimes you find them called GUID, which is the global unique identifier. So you use this to just uniquely identify values on your table, but there are 16 in digits. So you can also create your own data types as well. That's not really common because there are ways in which this has been mitigated now, but if you ever have to create your own data type, you can do that with SQL Server. And finally, there is the geography. There are a lot more, but these are just a few. So there is the geography, which is used to store geographic data. So longitude, latitude, and all these things can be stored in SQL Server as well. And this is how we store data in our columns in SQL Server, by specifying data types. So I believe all these things has cleared some understanding, and by the time we start using them in the future, you won't have problem understanding what exactly we're talking about. Thanks for watching, and I'll see you in the next video. Bye.